afternoon. So today's lesson will be based on linear and quadratic graphs. I'm going to show you a short way of drawing any linear and quadratic graphs. But we have to take note of the format of writing a linear graph. But before moving to that, let's consider the first one, linear graphs. So linear graphs, the first point, we have four types of graphs. We have four types of linear graphs. The first one, we have the vertical line, and the other one we have the horizontal line. The other type of linear graphs, we have the right falling line, and the last one now we can consider is the rising. So these are the four types of lines we can consider. So anytime you want to plot a linear graph, it can either fall on the vertical line, the horizontal line, the falling line, or the rising line. So how can a vertical line look like? The vertical line, anytime you see x equals to c, this line is vertical because like when you plot it, it's going to give a vertical line. For example, let's say x equals to 2. So when you plot x in your graph, you have a vertical line. And the other type again, the horizontal line. The horizontal line is given as y equals to c, which also implies, let's say y equals to 5. When you plot when y equals to 5, that line is going to be a horizontal line. For example, let's say we have this point. If you have this face given, let's say this is the line drawn, and this is y-axis, and this is x-axis. So let's say for x equals to 2, let's say here is 1, here is 2, and y is 5, let's say here is 5. So when we want to draw this vertical line, where x equals to 2, x equals to 2 here. So when that line is drawn, definitely it's going to be a vertical line. You see, we can also refer it to be the line of symmetry or the asymptote. So the other point again, the horizontal line, where we have y equals to 5. Y equals to 5 is this point. So when you draw that line, definitely it's going to give you horizontal line. So therefore, this line is a vertical line, here in x equals to 2, and this line is horizontal line, y equals to 2 or 5. So these are the two types of lines. We have the vertical line, the horizontal line. So if we consider again the other types of lines, after considering the vertical line and the horizontal line, we come again to the falling line. The falling line, we have it to be y equals to negative mx plus c. And the rising line is the same, but its gradient is positive. The rising line is given as y equals to mx plus c. What differentiates it is the falling line, it has a negative gradient, and that of the rising line, it has a positive gradient. For an instance, when you are given an equation 2x plus 3, since the coefficient of x is positive, so therefore this line is rising. So anytime you draw a rising line or a rising graph, the direction is going to be towards this path. For an example, is this a graph we are going to plot? All rising graph, it goes this direction. All falling graph again goes to the other side. So this negative of minus mx plus c, because of since this x, the coefficient of it is negative, so therefore this line is falling. So when you plot that line, it's going to fall this way. Since the coefficient of x is positive m, so therefore this line is rising. So when that line is drawn, the direction is going to be this way. So these are the two types of lines we have in case of the falling and the rising. So the overall now, we have four types of lines: the rising, the falling, the vertical, and the horizontal. Before you can plot any line, before you can plot any graph, the way to see it, you must know this line is rising, or this line is falling, this line is horizontal, or this line is what? Is vertical. These are the four types of lines we have to consider. Now, how can we determine? Let's lay much focus on this falling and the rising. So how can we know that this line is falling or this line is rising? Let's make basic points of review. Let's say point plotting. Let's say let's take the first one. We can think of any number 3x plus 2. right? But by the way, since this is the standard way of writing any straight line equation, y equals to mx plus c, the y and the x are the axis, wherein the y is the vertical axis and x is the horizontal axis. This m here is representing the slope of any line. So slope now is going to be the change in the y-axis or vertical all over the change in the horizontal axis or the horizontal. We can also refer this to be as rise all over run. You see, but this slope you can as well call it as the gradient. The gradient or slope there is the same thing. They refer the same. So slope or gradient is change in y all over change in x, or we can say rise all over run, or we can as well say vertical all over horizontal. You see, so this is how we can find the gradient or the slope. So this m here is representing the slope or the gradient, which if I change in y all over change in x, or rise all over run, or vertical all over horizontal. Moving forward, this c is representing intercept, not only intercept at y. So this is representing intercept at y axis. Why intercept at y axis? Because anytime you plot a straight line graph, the line must pass through y. Either it passes through the positive axis or it passes through the negative axis. Unless maybe if the intercept is 0. If the intercept is 0, like the graph is given like mx, so therefore 100% the line must pass through the origin because the intercept is 0. But any line given like this way, that line must pass through the y-axis. And when it passes through the y-axis, that point it passes through is what we refer to as c. And this c is the intercept at y-axis. So c is the intercept at y. The m is the slope or the gradient. The y and x representing the intercept, representing the axis for y being the vertical and x being the horizontal. Now, our case study here we have to follow. We are trying to plot this graph. Before we plot the graph, you know this line is rising. Definitely. So the line is going to move this way. Now, where will it pass? Since it's going to move this way, the intercept here is 2. Definitely the line will pass is 2, where y is 2. Definitely the line will pass at this point. Without plotting the graph, you must know the direction of the line and you must clearly know where the line will pass. So this is just a short format. So let's say the practical or the reality of it. Let's choose, since a line is a separation between 2 points, we can easily look for only 2 points. Let's say we have our axis xy. Let's select value of x to be 1 and other value 2. Now we are starting for the corresponding values of y when x is 1 and when x is 2. Now when x is 1, 3 times 1 is 3 plus 2 give us 5. When x is 2, 3 times 2, 6 plus 2 give us 8. We have these values. Let's say we plot this graph. So we label our axis. This is x-axis and this is y-axis. This point is the origin. Origin is wherein x is 0 and y is 0. Since the highest value of x here is 2, let's say for every 1 centimeters is 1 unit, y unit, and the highest value of y is 5. Let's say we make it at 2, at 4, somehow little small. Let me just increase this length. Here is 2, here is 4, here is 6, and here is 8. So if we plot this point, when x is 1, y is 5. X is 1, y is 5, and 5 is the midpoint between 4 and 6. So we have a point here. This gives us one single point. Now we move again. When x is 2, y is 8. X is 2 along this path, and y is 8. We have this point. You see. So if we draw this line, you see, the line will pass exactly where x is 2. So this is what I was telling you. This 2 is telling about the intercept at y. You see, because of this, the question of this x is positive. That's why the line is rising. And rising lines always move this way. This is just a technique. So this line, we can label it as 3x plus 2. Maybe we can also decorate it, giving it an arrow at the end. So this is how we can plot a straight line graph. Now, if we move again forward to plot the falling line, I told you the rising line go this way and the falling line will take the shape of this direction. Now let's use the same equation where instead of positive we use negative 3x plus 2. Without wasting much time, let's use the same values of x and y as we have here 1 and 2. As I said, the line will pass through x, y equals to 2, and because of negative, the line will be this direction. So it takes the shape of this direction. Now, let's find the corresponding values of y. When x is 1, minus 3 times 1 is minus 3 plus 2, give us negative 1. When x is 2, minus 3 times 2 minus 6 plus 2 is negative 4. So these are the values. Now, if we plot this graph, y, and we have our x, so the highest value of y is 2, let's say negative 2, and we have our negative 4, and here is 2, here is 4 according to the values, and x take the shape of 1, and here is 2. So if these points are to be plotted, when x is 1, we have y to be negative 1. X is 1, y is negative 1. Negative 1 falls between 0 and 2. So negative 1 falls here, and we have this point. We have a single point here. So when x is 2, y is negative 4. When x is 2, y is negative 4. So we have this point and we have this point. So these are the points. So if we carefully draw this line, it will pass exactly where this point serves us as the intercept. Because of there is 2 here. Always, these 2 is representing the intercept at y. So this is it. So if we decorate this line, it's going to be this, take the shape of this, take the shape of this, and this y, we can label it as negative 3x plus 2. So this is just a short way of drawing any linear graph. We'll pay much attention on the rising and that of the falling. You see. So now, if we kick back, we proceed to the quadratic form of a graph. Quadratic form of a graph. Let's say we take the quadratic graph. The quadratic graph, there are certain things again we have to take note of. Quadratic graph take the shape of y equals to ax squared plus bx plus c. This graph is called a parabola graph because when we draw it, it can give us 2 shapes. The shape can either be maximum, which can call as the cap shape, or it can be minimum, which we call as the cup shape. So the difference between this maximum and this, we call this to be maximum because the highest point of it is maximum and the lowest point of it is this point. So the U shape is always the minimum and the N shape is always the maximum. So why do we call it to be maximum or minimum? This is going to be our case study. Now, since we are y equals to ax squared plus bx, the quadratic again is in 2 forms. Like we can either be minimum or maximum. So how can you know this graph is minimum graph? So since for minimum graph, the coefficients of the quadratic term must be positive. So this equation is going to be y equals to ax squared plus bx plus c. We have that. We have that, and so for the maximum graph now, maximum graph take the shape of y equals to negative ax squared plus bx plus c. So this minimum graph is going to give us a U shape, and this maximum graph is going to give us an N shape. So it is minimum when the coefficient of x squared is positive. It is maximum when the coefficient of x squared is negative. These are the 2 shapes of graphs we have to take into consideration. Now, if we want to prove these points, if it is real or not, let's just take basic graph. Let's just consider the graph of y equals to x squared. If we plot this basic quadratic graph, we call it to be quadratic graph because the highest power of the equation is 2. When the highest power of the equation is 2, we refer to the quadratic graph. Now, how are we going to plot this graph? Since we have y equals to x squared, we can, since a curve can, 3 points can give us a curve, so we can choose random values. Let's say we start with negative 1, We can move to 0, 1 or 2. Let's take 1. So this point will be enough for us to verify that this positive graph, which is positive x squared, will give us minimum. And minimum there is going to be what? U shape. So now let's look for the corresponding values of y. When x is minus 1, if we substitute minus 1 here, which is minus 1 all square, which implies minus 1 multiplied by minus 1. Negative times negative is positive. 1 times 1 is 1, which gives us 1. So here is going to be 1. So when x is 0, 0 square is 0. When x is 1, 1 square is 1. These are the values. Now let's see how best we can plot this graph. We have this point, we have this point, and this is the y-axis, this is the x-axis. The highest value of x here is 1. Let's say 1, stop to 2. And here, no negative value of y, let's just say it's 1. So now let's try to plot this value. When x is negative 1, here is negative 1, and here is negative 2. When x is negative 1, y is 1. You know, y is 1 here, negative 1 here. So the intersection of these 2 points give us this graph. When x is 0, y is 0. It means at the origin. These are the origin. Both of them will be 0. Now we take when x is 1, y is 1, x is 1, y is 1. So give us a point. So these are the points. So start having our curve from the first point, which is this. We can start with dotted lines. Later we take the shape of the curve. So this is the curve we have. So you see how beautiful it is. So label it as y equals to x squared. Because of the coefficient of x squared is positive, this gives us a minimum curve, which is U-shape. You see? Without wasting much time, let's use the same equation again and we verify for the quadratic graph. The quadratic graph, let's consider the same equation. Instead of being positive, let's say here is negative. And same way, let's use the same values of x we consider as negative 1, 0, 1, negative 1, 0, and 1. So if these values are used, now let's find the corresponding values of y for both x. Now when x is minus 1, you know, for substitute here, it's going to be like minus into minus 1 squared, which implies negative into negative 1 into negative 1. Negative times negative is positive. 1 times 1 is 1 plus this negative give us negative 1. When x is 0, substitute here is going to be 0. When x is 1, it's not here going to be negative 1. So these are our values. So if we carefully plot this graph, let's say this is for y-axis and we label this x-axis. We do that in the beautiful way. Y is 1, let's say 1 and 2. X is 1, let's say 2, negative 1. Now we start. When here again y is negative 1. When x is negative 1, x is negative 1 here, and y is negative 1. So we have this point and we have this point. The intersection of these 2 points, the 2 lines give us a point. So when x is 0, y is 0, it means they meet at this origin. When x is 1 here, and y is minus 1. This is the point. Where they meet is the point, so it gives us this point. So you see, let's start with dotted lines to see how the curve is going to look like. So you see, so this gives us a perfect curve. So this is how beautiful it is. So this is it. So in summary, when the coefficient of the quadratic term is negative, we are going to have a maximum curve. When the coefficient of the quadratic term is positive, we are going to have a minimum curve. So these are the 2 shapes we should have for quadratic graph. And this quadratic graph, we can also call it as the parabola. Yeah, thank you. Stay blessed. Okay, another point again. Let me just refresh my mind. I just want to left out something. Let me just refresh my mind. Now, if we have graph of 3x squared plus 2, we know this coefficient here is positive. Definitely, this graph is going to be a minimum graph. A minimum graph is going to give us what? A U-shape. Let's say we have negative 4x squared, negative 3x, negative 2. The coefficient of this x squared is negative. Since it's negative, it's going to give us a maximum graph. So therefore, all graphs which have a coefficient of negative will give us a maximum graph. So these are the two shapes of any parabola or quadratic graph, being it a minimum graph which has a positive graph, or a maximum graph which has a negative side. So these are the two shapes. So thank you. Stay blessed.